Hi everyone, I'm Dr. Surjit Singh. Today we'll discuss the Leetcode problem, number of islands. Let us begin. In a given grid, 1 represents land and 0 represents water. An island is surrounded by all zeros. Land cells can be connected to each other vertically or horizontally. We are to find the number of islands. In the first method, we will use a recursive function to carry out DFS and perform backtracking. We are given a rectangular array of zeros and ones. 0 represents water and 1 land. Outside portion is assumed to be all zeros. If 1 is present around 1 in any one of the 4 directions, they are considered as connected. NR and NC are instance variables of the class. Num islands is the function in which grid is a two-dimensional list. It returns the number of islands, which is an integer. If grid is none or empty, the result is 0. NR is the number of rows in the grid. NC is the number of columns. To begin with, number of islands is 0. We scan the elements of the grid row-wise to look for a 1. First element is 0, so we move to the next element of the grid, which is 1. We increase the number of islands to 1. We call the recursive function to replace it and all its neighbors with zeros. Grid is a list which is passed by reference. R and C are sent to the function and can be changed independently in every call of the function. We replace 1 with 0. Now we inspect its 4 neighbors. R minus 1 is out of bounds. This means that there is no upper row, so we skip the first if. Left cell is present, but its value is 0, so we skip second if also. Down cell is present and its value is 1, which becomes a new pivot, and we call DFS for the new iteration. It is replaced with 0. Its upper cell is 0, so we skip it and process its left cell, and 1 0 becomes the pivot. It is replaced with 0. All its neighbors are either not present or 0, so all the 4 if statements are skipped, and we come back to the previous call. Processing of the down and right cells of 1 1 is pending. Both of them are 0, so this call is also finished. Now we need to process the right cell of 0 1, which is 1. So another recursion is called with 0 2 as pivot. We replace it with 0. 2 of its neighbors are not present while the other 2 are 0, so this call is finished. With this, all the calls are now processed and we go back to the main program. In the next iteration of RC in the main program, it becomes 0 2. This cell is not 1, so we move further. Cell 1 0 is also not 1. The loop continues till we reach 2 2, where 1 is present. So the number of islands is increased to 2 and the pivot along with its neighbor are replaced with 0 in the DFS calls. Cell 3 0 has another 1. So islands become 3 and the cell becomes 0. No other 1 is present and the loop terminates. 3 is returned as the final answer. Time complexity is of the order of m times n. Space complexity is of the order of m times n because for a grid of all ones, DFS will be mn times deep. BFS is non-recursive and takes lesser space. If there is a choice, BFS is preferred. Initial statements are the same. We start a pair of loops to scan the grid. Grid 00 is not 1, so we go to the next iteration. Cell 01 is 1, so we enter the if statement. We increase num islands by 1 and replace the cell with 0. We define a queue called neighbors with the tuple RC as its first entry. We start BFS by starting a loop that runs while queue is not empty. In each iteration, we pop out an entry from left and store the pair in row call. Its top neighbor is out of bounds, while its left neighbor is 0. Its bottom neighbor, that is cell 11, has a 1. We add it into queue and replace the cell with 0. Its right neighbor is also 1. We add this also to queue and replace it with 0. In the next iteration of the while loop, we pop out 1, 1. Its left neighbor is 1, so we add it to queue and replace it with 0. All other neighbors are already 0. We now pop out 0, 2. No neighbor of this is 1. So we pop out 1, 0. No neighbor of this is 1. As the BFS queue is now empty, the while loop terminates. We go back to the for loops for RC pair. This will progress in search of another island. The two loops continue till next one is found at 2, 2. Number of islands becomes 2. The cell is replaced with 0 and a new BFS queue starts. This will replace all the cells of this island with zeros as the queue becomes empty once again. RC pair becomes 3, 0. Number of islands becomes 3 and all the cells of this island become 0. No more ones are present in the grid, so RC loop terminates and 3 is returned as the final result. Time complexity is of the order of m times n. Space complexity is minimum of m and n because even in the worst case, when all the cells are ones, BFS queue size is minimum of m and n. Thank you for your time. Please like the video and share it with your friends. Please subscribe to my channel.